We will wait for a few minutes and then start. In the meantime, while we're waiting, if someone has any questions, they can ask. I hope you can see my screen. Okay. Does anybody have any questions before we start? Okay, I guess we can start. Um, so past few weeks, couple of weeks, we're studying about classes in C++. Just to recap, this is something also we discussed last week, but again, just a quick recall. So classes are some sort of you can think of it like a custom or user-defined data type. And depending on our use case, we write classes, their member functions, data members, and then we can sort of mm, have demarcation or sort of a segregation of what kind of data we want. So like they could be private to the class, they could be public so that they can be accessed outside the class. And then like similarly for functions also. So and then all this with the data members and functions, we have something called a state of the object, which is essentially like what are the values that the data members themselves contain. So that's there. And then altogether with all these features, we have something called an encapsulation, where the whole thing just comes together in a way. Here we have seen something called a complex class where we want to define complex numbers. So with some real and imaginary parts. So we wrote a constructor for it, right? And then a destructor. After that, it's essentially like writing functions to get the real and imaginary part. You can have them not like you can have private variables which store those values and then access them through functions. So essentially, these are like getter functions, right? And then through calls like this, you can create different objects and print the real and imaginary parts. Okay. I hope this is very essential. This is essentially what classes start out with, and let's see some more features today. Yeah. Okay. So let's start with something called a static variable. Okay. So we'll start with hash include. We'll, for printing as usual, we have IOString. Um, I'm going to use strings also. So I'll have include string. Then I'll create something called a data. Okay. Uh, which as private variable string denoted by something underscore, like ID underscore. Then define public functions, which will be first the constructor, something like const, const string, sorry, const string and a string, then which essentially takes just a second. Yeah, it's okay. I think we can just do it this way. Okay, yeah. So we saw some previous examples of static. I want to show some other examples. So yeah, okay. So we have string, and we also discussed pass by reference. So if we take, let's say, a string with passing by reference ID, then inside the constructor, we will define like essentially store ID underscore, right, which is the private variable to data, uh, which will store the ID that is given to the constructor. Then we can have the definition, which will be printed when the constructor is called, which will be something like standard cout struct. Then the internal variable itself can be constructed now because it has been set standard. Now, yep, that's it. After that, we can just destroy it. So tilde data, close this, and then have some kind of message in a way to say that yeah, this destructor is also called. Destroy. Same. Now, this is a class that we wrote. What we're going to have is static members, right? So I'll have another class called my class. So I'll define a static variable, which is of this user-defined data type, data, and call it, let's say, d1 underscore. Similarly, I'll have another static variable. Let's call it d2. Okay, and this class. Now I can have, so these are defined, and I'll have int main function, right? Now, important thing to note here is for to use static variables which are inside these classes, they need to be in the scope. So if you think about it, this static variable d1, which is of data type d1, which is of data type d data, this both d1 underscore and d2 underscore, they are not accessible in main because they're not in the scope. So you also have to define them in this for being in the scope. You have to define it like this. My class. Then since that is where it is defined. So after that we just sorry, if data, and then you give some kind of constructor. Like for this constructor to work, we have some. It takes some kind of string. So you actually don't need to pass by reference. You can just pass by like just have this way. So it will be a copy. That is also fine. Then let's call it object underscore. Yeah, right. This will be the construct of the first object. Similarly, will construct d2, which will construct object 2. Okay. Notice that I don't need to call any what do you call the uh, function here because all the stuff that will happen is when before my main is also compiled. Um, these things will also get compiled, and accordingly, since this is a static variable, its constructor will also get called. So you really don't need to have any body. You can have some body in the main, but it's not really necessary. Now, why do we do this? So let's compile and then understand what is this program even doing. Okay. So maybe I should have guys asked you what do you guys think is happening here? So just to summarize what we have done is we have data class. Okay. There we have defined a standard string ID underscore. So can somebody tell me, is this ID underscore private or public? I haven't defined it as private or public, but what do you guys think it is? Anyone? Yes, that's correct. It's private. So do remember, if something, if a member function, if a member variable, a member attribute is not defined, it's not specified, it is taken to be private. And after public, whatever you specify are in general public. So you have to actually have constructor and destructor as public, because they need to be known outside the class, right? So when you're trying to construct an object, they need to be known. So you can have them as inside private, but then there's no point in creating the object, right? So yeah, right. That's correct, Simran. Okay. So that's the data class. Then we have the constructor, which takes ID, right? Then when it takes the ID, it sets the ID underscore, which is its own member, right? And then calls the this body, which is the construct, and then just prints the ID underscore whatever it was set to. Now, similarly for destructor. Okay, that is the whole data class. Now, what's happening here? So what we defined is another class, some kind of my class, but we have defined a static variable here. Okay, so static is essentially something which um, think of it like it will be accessible by its data doesn't change. It's like you can access it outside also, right? So for this static, we define data type data and then d1 underscore. So this is how it is defined, right? It's the order of this is the definition. There is no initialization yet. Okay, so it's just the definition of both d1 underscore and d2 underscore. Okay. Now what we do is we go to we actually uh, try to construct the object d1 underscore. So here we're actually initializing. So in initialization, you have to pass the data, the type data, and then you're actually specifically accessing through my class namespace. In a way, you can think of this way, the D1 object here. Okay. And then to construct, we have to pass some kind of string, right? For the it is the essentially the parameter that the constructor takes. So you pass that, right? So here the D1 will be called. Okay. So construct this is what is printed, and then it goes to the next line. So D2 is called, right? So D2 is called, and then the whole when the whole program ends, so the destructor gets called, and then this is what it prints. Okay, great. So then now the question, what happens when I switch these two? Okay, notice this is more slight change where we are just switching the two lines, D2 and D1, where the definition just changed. But notice I have kept the uh, definition, yeah, the initialization part the same. So what do you guys think will happen? Anyone? We can always print and check, yes. But any answers? Okay, let's try and print. So yeah, essentially it's the same thing, right? We saw an output where it just printed the first object, then constructor of the second object, then destroyed the second and then first, right? So this is an important point here. The order in which you define the objects inside, like as static inside the class, that doesn't matter. It's the order of initialization that matters. We can actually check that also. So let's keep this as original and then just change these two. Yeah, so you see here I defined a object like declared object for, so these are definitions. So I declare object first with the constructor. So it's like initialization. So I initialize something first. So its constructor gets the called. So hence the object to construct gets printed, then object one. Okay. And then destructor as usual. Same. Okay. I hope this is clear. So I any questions? Okay, I guess we can move on. Right. Okay, so let's take maybe one more example. Yeah, so the recorded sessions will be uploaded to YouTube, and so PMR should send you guys a link. So for all the classes that I've taken for these sessions, they should be there in YouTube and you should get a playlist of sorts. I can probably put that in the chat also for the link to the videos. Yeah, okay. Let me just check. Should have the link to the playlist. Yeah, just paste in the chat. Hopefully you guys can access this. So with each sessions, I'll keep updating the this playlist. This should be available to everyone. And yeah, in any case, if you guys are not able to access anything, yeah, sure. You're welcome. So if you guys are not able to access any of the material that I discussed or anything, just do let me know also, and then to contact the NPTEL support, they should be able to help you guys out. Yeah. So yeah, sorry. Yeah, so that takes care of the lecture, the recordings. You guys should also have access to the codes that I discussed. I just put them in a Google Drive, and then uh, that's what takes care of it. Maybe I'll share that also today. Just give me a second. Check if okay, I'm able to access the code. I'll put this on in the chat. Today's lecture also, after it ends, I'll update this two links. Okay. Okay. I guess we can move on now. Yeah, that's essentially what I wanted to discuss here. Is what I wrote. That takes care of this. Static, and then okay, let's take another example. Okay. So static. We keep all this thing. Again, let's define something called my class. Okay. I'll have private variable x. Okay. Then public define a function. Okay. Which will be void because we don't really care about the data return data type. Then set this variable to, let's say, 15. Okay. Then we have another one which is, let's say, called print. Okay. Which not only just has a standard cout, okay, like this. But before that, what I'll do is set this value x equals to x plus, let's say, 5. Okay. Then yeah, I have to end this also. Then this print will just print the value x. Okay. Yeah. Now that's my class. After that, yeah, we just have main function, right? Sorry. Yeah, where I will have a return 0 by default, and have some I'll call this my class, and then maybe yeah, have two objects, one object one, object two, and right, and then so these are distinct objects. Okay, then I'll have object one dot. I'll call the function get, which is this function, right? Then I'll end it. Okay. Then object to dot get. Okay. Then I'll have object print, one print. So yeah. And similarly, object to print. Right. Okay. Let's try printing this and see what's the result that we get. So do notice I haven't declared any static here. So this should be clear. Whatever the output that we get, it should be clear. Like what are we going to get, right? So first is what's the concept that we're trying to learn? So the object one get. So we created two objects. So this whole definition exists for both object one and object two. The whole get, print, internal variable x, etc. Now when we do get for object one, it returns x equal to 15, right? So that is fine. But did I print? Oh yeah, sorry. So there's no print statement here, right? So it sets x equal to 15. Do notice I can actually print. I can have this print statement here also to actually see that it when it calls this function, what happens. Okay, let's go step by step. It prints the value 15, right? Because I've given it to call inside get to print the value. So it in the function get, it sets the value 15 and also prints it. Okay. So let me remove that for now. Then next is also get. So for object 2 also internally, x is set to 20, like x plus 5. So that's 15 plus 5. Now, important thing to note is when the object got created, object 1 and object 2, both of them had the variable x, but it was not set to anything. Okay. When we call the function get, it was set to 15 in both. And then when we call print, it is set to x plus 5. And then we print, when we print it, we sing the value 20 each. Okay. Important thing is here x itself is the internal variable, right? It's private and private to each of the object. Okay. Right. So let's see the same thing, but with a slightly different example. Okay. Well, I'll have same hash include and string, and we make the same class, my class. Then I have it something called a static variable, static x, okay, integer, sorry. And then have the same public functions. Okay, just properties. Not required. Right. Yeah. Again, remember about the scope. So this same static variable needs to be defined uh, outside for the scope so that we can call inside main also. So we need to define this. I'll define the same static variable class. Okay. Right. To let's say 0 is fine. Okay. It is static, but we need to have a definition for the scope, right? So then integer, okay. No parameters for it main, but it's fine. And the return 0. I'll have my class again object and object 2. Okay. Or you just repeat the same exercise. Now, okay. The difference is that previously we had internal variables x, which were internal or private to each object, object 1 and object 2. And then now for this second example, what we're doing is we have the same variable x and almost doing everything the same, but this time the variable x is static. Okay. So essentially a static variable is shared by all the objects of a class. Okay. Here the x is not shared, it is private to each class. But here every instance of the object shares the same x. Okay. So can anybody take a guess what will happen if we try to print this? Recall the previous example where first get what does get do, and then what does print do for each of the objects, and then we move on, right? So can you think in the same lines? What will happen when we call object one get, object two get, then print statements? Okay, this is the answer type. Go ahead. You can unmute yourself also if that is easier for. Yes. Okay. So get will be 15. Okay. Uh, right. And then print itself will set x plus 5 to 20. And then again, when we try to print, it will set to it will print 20. Okay. Is that correct? Let's print and find out. Right. So X is 15, yes, but things will not be printed. Yeah. So because unlike slightly before when I had a print statement, they won't be printed. It's only when print is called where I have print statement. So only two times will get printed. But yes, that's correct answer. At least I'm not saying it's wrong, but it's just a slight technicality is what I'm saying. Anyway, it's actually correct answer. You understand the thing, so that's good. That's good. So um, yeah, like I was saying, so get will set x to 15. Okay, and again for object to get will set to again 15, which doesn't matter because x is already 15, but you are setting it to 15 again, so that's okay. So when you call print, it sets to x plus 5. Okay, and what else? Yeah, 15. That's it. Okay, I hope this is clear. Uh, yeah, okay. So that takes care of static. Okay. Oh, my bad. Actually, the wrong one I did. It shouldn't be that. Yeah, it should be 25. So yeah, right. So first get sets x to 15. So I maybe I'll write the same thing here also. X equals to 15. Here also x equals to 15. But important thing to notice, these two x are different. So you can think of like x1 and this is x2. Here this is x1 because object 1, right? So here it will be plus 5, so 20. Here it will be x will be 20. Okay. Yeah, so x2. Yeah. Because again, when you call the print, internally it will increase it and then we are printing. But here it's the same x. Okay. So x equals first it is set to 15. Okay. Then x is also set to 15. It's the same x. Okay. Remember, the object 2 also has access to the same x because it is static. both are set to 15 in these lines. Okay. Here what will happen is the x is incremented to 20. Okay. And then here the same x is also again incremented. And remember the print statements are there inside this print functions only. So hence we see the 20 and 25. My bad. I compiled the wrong program. So um, this is something essential to understand because static variables are shared across objects. So those values, when they change, it is accessible across uh, objects. Okay, and the behavior also we can see with this example how the values change. Okay, so important thing to note. But yeah, thanks. Yeah, it was a good try. I do encourage to think about this because then um, if you're participating and at least thinking about the problem when I'm discussing, so at least that gives the clarity and you understand the concept better. So I do encourage to participate. It's okay if it's wrong or you're giving some answer at least. So it's your thinking, right? Yeah. Uh, do notice the difference. Okay. So first one, we did not have any static for X. And the second one, we do have static. So X is shared. Okay. Right. So that is about the static function. Okay. So next, I guess we'll discuss this function, I'm guessing. Okay. Yeah, I think I'll discuss this function. So yeah, discussed this part last week also, maybe not completely, but anyway, we can just go through over it again. Yeah. So what is this this guy? This. So it is essentially a pointer to the object of this class. Okay. What is it? So this is I have a class. Okay. So I have a class called my class where I have public variables x and y. Okay, great. Now I have a function also public, which I can which takes for integers a and b. Okay. What it does is it here I am accessing the member variable x of this class, which is x itself, explicitly. Okay. So since it's a pointer, do remember when we used to access object members of any object. So for example, here object is a data type my class, which is also you can think of like the my class class. Here I'm accessing its member uh, attributes as of x and y through the operator dot. Okay. Only difference is that when the object itself is a pointer, okay, let's say think of it like my class, but pointer. Okay. So this is the data type, my class pointer. So you have to use arrows. That's it. That's it. That's the difference. It's just the way you access things. Okay. Now, what I'm doing here is this one explicitly sets x to a. It takes the value a and b. It sets x to a, y to b. Now, the difference here is that since y is accessible for a class, any internal variable is accessible to it, private, public, protected, anything. Now, it can set y to be b, but with this line, I'm explicitly saying that the internal variable x that it has there, whichever is accessible to the class is what I'm setting to a. Okay. And I have another function where I'm just printing the address of this. Okay. That will be inside the function. It's inside the body of the function func. Okay. Now, what I'm doing is we declare object. Okay. It doesn't have any constructor. I mean, there's be a default constructor, so we don't need to worry. So just define without any brackets or anything. So my class object. Then I define it two integers p and q. Okay, which will be 4 and 5. Then just pass them. Okay. Now, uh, as usual, so a is set to 4 and b is set to 5. And then we are printing those guys. Okay. Easy. Yes, now it's and out. Okay, should work. Yeah. So as we can see, 4 and 5 are printed because that's how we access the object x and y. All right, of this object. of class, my class, and internal variables x and y, but they are public. So I use the dot operator and you can access them in public. So I get 4 and 5. And also because this function has the address like this line, so this itself is a pointer. So if you try to uh, print this, it prints the address to this object. So hence that is what we're getting here. It's a hex. So hexadecimal notation. So 0x, and then it just prints some address, right? Similarly, to confirm that this is the address of the object that is getting printed, I'm also using the ampersand here. Okay. And we can see they are printing the same thing. Okay. I hope this is clear. This is essentially uh, how the object pointer itself is accessible inside a class. Okay. Okay, good. Right. Now we can move on to something, a concept called a friend class. Does anybody have any questions now? Till now, before we move on to the next topic? Okay, I guess we can move on then. Um, Today let's learn something called a what's a friend class, right? So, um, so something to note is to distinguish. So we define something called public, something called private, and something called protected. Now, thing is, when we have a class, we can actually make derived classes. So using a certain class as a base, we can create more classes out of it. Okay, so that's called derived class. Now, when we do something like this, okay, we'll also maybe learn about that. That's called inheritance. But when we do something like this, or anything where we're accessing the member functions of the object, okay, or its derived classes or anything, we want to keep data separated. Okay. So for example, I neatly keep my member variables x and y and the function func public here so that I can access them. But sometimes I want to keep certain variables private to the class, right? Like we saw, I think here. Um, Yeah. So this is private, real and imaginary are private. IM variables are private here, right? Now, let's say when we have derived classes, those sorry, okay, same thing. So these variables which are private, they won't be accessible to the derived classes after inheritance. So when you're trying to build more classes out of this class, this these variables are private. Private variables are not accessible anywhere to anyone, only to the class itself. Okay. Now that is one level of uh, you can think of like in a way it's sort of a scope where you don't have access or not, right? So that is one level of protection of data. Okay. Second is to have public. So when something is public, everything can be accessed. So outside the function, outside in like main or something, you can access any member of the object. Now, there's a third kind, which is called protected, which says that only the derived classes can access those variables. It's similarly written like this only. Protected, okay, with his colon, and then you define whatever you want. Now, the nice thing is this with this protected, now you can have a sort of a private data, but it's just not only private to um, itself, the class itself, but the derived classes can also access them. Okay, so three levels of access specifiers. In a way, you can think of it like it's how much access does anybody have to our class. So the private, with private, the variables are private to only the class. Okay, so every function inside the class can also access the variables. Protected, the class it's accessible to the class and only to the derived classes, not outside. So here what I called was like public functions only. Okay, and rest of them are public functions. That I guess it's clear. Okay. Now, keeping this, we'll come to these derived classes and protected variables later on. but just to keep, just to have them have this and keep like back of your mind. So it's also important to keep in mind, because now we think about friend classes. Now, why I talked about this three types of access specifiers is with friend classes. Now, when you make other classes friends of this class, okay, they can access the private variables also. That's the only difference. That's the main thing here. So normally you can't have private variables accessible to anyone, but with friend classes, you can have access to the private variables also. Okay. Now let's see an example. Okay. Again, as usual, I include I have string. Okay. Then I define a class. My class. Okay. Private variable integer data underscore. So then public with my class. Then write a constructor. I then data set underscore to. Is there a question? Or okay, data to I, right? No body required. Yeah, let's we'll have the constructor just empty. You can print actually. Why have it empty? Let's print the constructor. Constructor. Yeah, let's take an integer. Let's print that also. Yeah. Then what I'll do is I'll have inside this class a friend class, or or like a parent function itself. Okay. Function selected type. Okay. The constant takes an object from my class. Okay. So this function display is a friend function, okay, but its definition, again, it should be accessible, right? So we have to define it outside also. And as you can see, I haven't given it any body also, so I'll define it here. Okay. Maybe just copy this. Okay, then write the body. I'll have, you know, the value data. Excuse me. Right. Then access the data, which is here. There's a difference here because this is a this is important to learn note. The data underscore is private to my class, like private to the object A. Accessing it something like A dot doing that, it generally should not be allowed. Okay, but since display is a friend function here, this is okay. Like, let's try to print it. We'll define a class object A. Let's call it a new name. Okay. And then we need to pass the constructor. Okay. Values, then display, and pass the object. Yeah, okay. I guess we're all set. So G preference, output, out. Can anybody tell what will happen when we try to print this? What will be the output for this program? Anyone? Okay, let's print and see. Right. Okay, so constructed takes the value. Yes, that's correct. 10. So the value is constructed to be 10, like that's what we pass, right? Now constructed takes the value I, so it has the access to I, so it prints that. We can actually do it this way also. Print data here. Yeah, it prints still prints 10. Now the nice thing is because because it's the constructor, so the parameter variable is already accessible. That's like I guess that is clear. But the internal variable is also accessible, which is the private data. And that variable after it is set is what we're printing. So here we can see that, okay, now while the constructor was called, the data was set, and now we are able to access it. Okay, so that is 10. Now we defined something called a friend function, and with the friend function, we're able to access the same internal data. Yeah. Okay. Now maybe we'll do it. Now, sorry. Uh, Generally, this is not uh, possible because data underscore is an internal variable, which is a private member of this my class. But because display is a friend, okay, it has access to the private members also. Okay. So when we call display function, display is not a member function or anything. It's just a friend function. I mean, yeah, it is defined here. It's like a also you can think of like a member function, but it has its own it's defining the scope of the main also, right? So it's not like I'm calling a dot display and then accessing the member. Okay, I hope you understand understand the difference, the distinction between calling the member function directly. So here display if it would have been not a friend, but I would have moved the whole thing to inside and then let's say commented this. Then I can't call this because display is not there in the scope of main and it doesn't see this. So, but I'd have to do something like a dot display. Obviously, passing the object doesn't make any sense, but imagine this also wasn't there. This is okay. We can do this and then this line would have worked. I'd have to call display part of display, which is the member of the object A. But yeah, that's not what we're doing. Okay, so I hope you understand the difference between these two. Okay. I hope this is clear. This concept about friend functions is also clear, right? Any more questions? Yeah, okay, great. I guess then we can move on to the next concept. Yeah, great. Which one should I cover now? I guess I can go to inheritance. Yeah, let's do inheritance. Okay, a very basic example, simple example for inheritance. So I'll define a class. Yeah, I don't need to include anything, but as the usual we're used to live, might as well include it. I don't need it, but think of it like a ritual. We always have outputs to print from. So define class B. Okay. Then I'll define internal variable, let's say, yeah, data. Okay. Which will be 1B underscore. Okay. Then this is private, and then I define something of a public variable will be data 2B underscore. Okay. Right. I have class B. Right. This is my whole class that I've defined. So using this class as base, okay, and maybe write it here. Right. This, uh, what I'm going to do, now construct is a derived class. Okay, class, let's say D is derived. B is the base class. I'll write. Okay, and D will be my derived class. What I do is I use this to construct. Okay, and similarly, this is the body for the class. Here, I define something called a derived class D with colon and then public B. So it knows that it will use B as a base class and then create this derived class. So this is the derived class. So right now, for very similar to the any class, and let's say the class B itself, I can define some internal variables. So they are like data one B underscore, okay, and then public will have some B, let's say two. Okay. Now, important thing to note here is that when you do something like this, uh, yeah, I have to close this also. When you do something like this, the uh, derived class also has the base class variables and functions. So, okay, maybe I'll give an example when we want to have a base class and a derived class. So think of it like cases where you can have a general statement like, let's say, vehicles or something. And what kind of vehicle? Is it a two-wheeler or is it a four-wheeler or something? So think of a largest set could be a base class, and on top of that, we are, in a way, you can think of it like narrowing down what kind of uh, that object is. So let's say it's some vehicle, and then from the with derived class, I'll have again a class of, let's say, two-wheelers, and specifically which kind of two-wheeler will be the object, right? And it will have its own attributes. So two-wheelers, let's say some properties like what is its wheels, the spokes, and all, like whatever, however you want to describe that object. Okay. Um, Sorry, the object. I did not get you. So yeah, that's the way we'll define the object. That's correct. So I haven't written the main function. So let's write that and have it return 0 as usual. I'll define the object with the class B. Okay, and B I can also declare something like object. Okay. Now as uh, Again, even if it's a derived class, important thing to note is it's still a class. So whatever we have learned about a class also applies to a derived class because it doesn't change the fact that it still is a class. It has its own variable which is private. It has public uh, like if you specify public, then these variables will be public. Similarly for functions and so on. Similar to class B. Now this object I've defined is small b is the object for class B. Object is the object for class B. Okay. Now important thing here is what happens when we declare something like a derived class. So what happens exactly is this class D has all the members of class B. So data 1b, data 2b are also present inside object. Okay. So when we declare when we define B, it will have its own data 1b and data 2b. True, granted, we can only access inside main function only the data 2b underscore, not this one because this is private. But that variable and this variable both exist inside data D object of data type B because this is a derived class. Okay. Yes, it will have its own variables which are data 1D and data 2D. But on top of that, it will have these variables also. Okay. So I can access something like object dot 2D. Yes, this is allowed. I also um, I can also access data to B, okay, but I have to use the namespace B. Okay, right. I hope the idea is clear here. So think of base class as uh, a framework which on top of which derived classes are built, okay, but it doesn't stop derived classes to have more member functions or member variables other than whatever are present inside derived class. Okay, right. Now, maybe we can move to slightly more complicated, like little more. Uh, yeah, maybe our next example will clear things a bit more about inheritance. So essentially, this is what inheritance is. You derive a class from another base class, okay, and then inherit these variables. We can do the same for functions also. Okay. So let's take another example. Right. So I'll define the same class B, okay, but this time I'll have public functions. So, sorry, point f takes an integer I, void g takes integer I, then the class ends. I'll derive a class D from public B, okay. Then again to define public, yeah, that's it. Thing is, I can access this function because it's a derived class. What I can do is have name, okay. B define object B, D define object D, and to since it's a public function, I'll call the function one. Okay, this is okay. I can probably print it also, whatever it's taking. Uh, I'll include the header file of that. Standard C of print I. And same thing I'll add in here also. Okay, that takes care of it. So if I call the function one with one, it should print that value, and it's accessible because it's public. Okay. Similarly, I can access G also, right? Let's try that. If I compile the second file, right? Then, yeah. So I think the output is so I think expectable. So we defined objects B and D. So B object is of class B, okay, and D object is of class D, which is a derived class of B. Okay. Do note I wrote some public, but again, it's also okay if I don't, right? I just derived it and did not have any constructor. So I'm expecting it to just take the default constructor and use the default destructor also. Actually don't need to define anything if I just want to use the functions, only use the functions inside which are already defined in the base class B. Okay. So now let's see how we can do that. I think this is clear. This is what we have been doing till this, excuse me, till this line where I'm accessing the function f of object B. So this line is called, and it just prints I, right? And G, so it prints this line. So it's pressing whatever. So maybe I'll take I, and then the 1 and 5 are the values that are printed. Okay. Now let's see if we can access the same function via G, via D, sorry. Same function f and G via D. Okay. Let's give the same input also. Okay. Yeah, 1 5 1 5. Now to see that it's actually being accessed from object D, let's comment this. Yeah, 1 and 5. Now let's have them maybe give some different values to actually check, right? So yeah, this is what the values that we expected, and it is what is printing also. So the function f of object B takes value 1 and prints that. Similarly G, but again, important thing to note here, the object B is the functions f and g are public, so we are able to access them. Not only that, because it is public, for the object D also, we are able to access them. Okay. Oh, sorry, my bad. Here it should be G. Again, anyway, it's the same function that happens. So okay. Change it to star. That's better. We'll at least do something different. So yeah, 1, then times 5 to 10, 11 is printed, and then times 2. Okay. I hope this basic idea about inheritance is clear. Okay. Right. Now let's learn another concept about, which is again from inheritance, which is override and overload. So we know overload when I defined function, let's say I take, let's say, integer. I have some body for it. I'll take, let's say, the same function. I'll have, let's say, double. Okay, so a different data type is the input, and let's say float. Okay, so on. Like so, taking for the same function, having different bodies. Okay, so you can have different bodies also for this, and taking different data type. So this is essentially what is function overloading. Overloading. We are overloading the function with different data types, and according to what data type you actually pass, the corresponding body will be called. I'll print it here something, and or do call some other function or something. So depending on data type, you can have different definitions, like in a way like the body of the function, but use the same function actually, same name. That's function overloading. Now We'll see a similar thing inside classes. Okay. So uh, have a comment so that things are it's probably not confusing later. Okay, let's start by defining the same class B. Okay, I'll have which will be the base class. I'll have public functions void f take integer I. Okay, then g which takes integer I. Okay, here maybe we'll not. Yeah, that's fine. I have to end this function. Yeah, class D. Okay, again, sorry about this. We want it to be derived, so let's do that. Define public parts. Then, yeah, same. What I'll do is, previously, here I had some variables, that's okay, but I had different variables, say different names. Here I did not define anything, so it just took these functions or variables, whatever. Here also did, but I had extra variables, right? What I'm going to do here is have the same function itself instead. Okay, so it's void type f integer I. That's it. Here also. I'll take g, but this time I'll not have it as integer. Maybe I'll have it as float. Okay. Now ends this. Okay. And I'm always free to define something new also, like h something. Let's say we'll take double lines. Now, because it's a derived class, derived classes can have their own. Sorry, just a second. Yeah, yeah. So derived classes can have extra functions. Okay, and they obviously inherit the variables and functions of the base class. But what extra thing you can do is you can actually overload them, okay, and override them. Now, here, what's happening is I have the same function g, okay, but here the input was integer I, okay, but here it's float I. The variable name doesn't matter. What's important is it takes input float. Here it takes input integer. So this is function overload. Okay, because D has access to the same function G, right? So here, when you call something like this, it will try to uh, overload the function G, right? Depending on the input that you're passing. So with G, with any object of D, so like we defined uh, small d as the object of D, right? So when you try to call D dot G function, and then depending on the value you pass, corresponding function will be called. Assume that there is a body of the function. I have not written it, but assume that there is a body. So depending on if you're passing it's a 1, so then this function will be called. And if you pass 1.0, which is float, so this will be called. Okay. Again, you're free to have more functions also, which are not defined in the base class, like h, right? And whatever data type you wanted for that function. Again, yeah. So this is the extra function. This is function overload. And then important thing here is function override. Okay. Why is it an override? Look at the function name itself, but also the definition itself is also the parameters, input parameters are also integers. So let's say you have some kind of definition here and also some different definition here. Okay. So when you call it this function f from derived class, sorry, from derived class, this body of f will be used, not this body. Okay. If you call the function f from object of B, then this body, whatever body F has here in this line 8 will be used, not this line, because base class doesn't know anything about derived class anyway. But derived class knows about it, and it overrides this integer input of F. Okay, so this is called function override, which derived classes can do, which are like when you inherit classes, and you can also overload them, okay, with different input parameters, like we did with G. As usual, you can always have more functions inside your inherited class. Okay, I hope this is clear. Any questions till now? This is uh, some important thing about inheritance. Okay. Maybe we can call and then see also. Uh, write the function. So as usual, I'll define object B of type class B, then object B, right? Then B I can call function F with parameter 1 because it is integer, it's allowed. I can call B dot G. I can pass some integer. This is also okay, allowed. Then I will call the function F of 1. Okay. I can pass anything, so I'll pass it. Remember, here if it had, actually we can maybe try this out. Under cout, then I need increments. Okay, I can use couts. So I will be printing I, just I here. Okay. With this, let's say we print 2I. Here I'll override it, okay, and not print 2I, but maybe I minus 1. Here is overload, where I'll print maybe not 2I, 3I. And with G, it can be like I divided by 2. Now to call the functions. So D, G will have, say 9, but it needs a float, right? So let's give work. Then sorry, D dot H, where I pass, let's say 17. Yeah. Now let's run this. It is, oh, it's not 2, it's 3, sorry. This, oh yeah, my bad. So I pass 1 to F, right? So it prints I, so that is expected. Then I have G, which takes 4, so it prints it twice on that, again integer, so not a problem. Then I call F with 8, so again notice, because it is overridden, it will print because it's called from D, right? So this function F is called from D. So if I pass 8, it will print -1, so that is 7. Then G, I pass something like I, right? So it'll be 3 times I if it's float. If it's integer, it will just print twice of that. So here I pass 9. Apparently it took both as uh, float, so hence it's printing 27. But yeah, let's maybe typecast it to integer. That might work. And the third one is 17, so half of that is double. Yeah, that's 8.5. see if this works. Okay, it's still pending 27. Um, yes, it's not taking this integer 9. Okay, that's fine, I guess. Yeah, maybe we can explicitly define a to not a value, let's say, to be 9, pass that. Hopefully that works. Still taking 27. Yeah, that's okay. I guess that's because of the compiler. Anyway, I hope the idea is clear here, right? Whatever is the inheritance uh, works, how the from base class we have derived classes, how inheritance inherits the base classes, functions, memory variables, and everything. How we can overload uh, functions, friend classes, right? Which if friend function, and there are classes also. So with friend functions, you can have same function access the private members also, right? Generally, it is not possible, but with friend functions, you can now. Uh, then we have this pointer that we discussed, static variables also, and yeah, that's I guess that's the summary of what we learned today. So if you have any questions, I can take or yeah. Maybe we'll take about protected variables also. Um, I can review some of the stuff, but maybe let's take this and then let's discuss the protected access specifier also. Yeah, define something called protected here. And protected. Now, if I try to access objects like v, right? So v dot, if I try to do this, this is not allowed because still, even if a data member is protected, you can't access it outside the object, outside the class. But derived class D can have access to it. Obviously, it can't print it because it's not public. But let's say I have some kind of function here, f, and have some kind of body, right? Here it will be able to access this data. It can't access data 1b, okay? Here also inside the class itself, but it can access data 3 b underscore because it is protected and public anyway. Everyone has access, so that is naturally accessible. Yeah. I hope this is clear. So this is something also important. The we call it um, access specifiers, which are private, public, protected. Also useful in while having inheritance like derived classes. Okay, right? And friend classes we saw something also we saw. Yeah. Okay. Anyone has any questions? Okay. Um, With this, we can end the class. If you have any questions, you can stay back. I'll be here, or you can feel free to leave. Yeah. Again, I would encourage everyone to practice some questions. In the slides, you can find some questions, and you can again go through the examples that I do in the sessions. Um, you can find questions online also to practice about inheritance and static, and basically whatever topics we covered. Be it yeah, again inheritance, derived classes, um, private, public, protected, friend class, friend functions. Um, what else? Yeah, what and previous whatever we covered and previous weeks. Yeah.